All right, we gotta get to the new stuff, you guys. We're not saving this. New stuff, yeah. Here's I posted the new spreadsheet. I moved the weights over for everything that's been completed. Everybody see this? What percent do you think we're at as far as graded items? What percent out of this class out of 100%?
65. 70. 55.
65, 70, and what was over here?
55.
55. Well, that's low. But let's see. 62.3. 62. So you still have 38, 37% left to go as far as graded materials to change your grade if you're not happy with it. The totals on black or on canvas should equal what you would get on this spreadsheet. I always like to do a quick example after the quiz. I know we've spent way too much time on stuff already, but I want to do one. I want to point out, in-class assignments, we didn't do one in week 10 as planned. We ran out of time on Tuesday and we had the quiz on Thursday. So because of that, in-class assignments went from 1.25% to 1.3636, each one of them now, because I had to spread it over less in-class assignments. So that changes everyone's grade. Meanwhile, let's pretend this person got 100 on the first homework, 100 on the first in class, a 98 on the second homework, I don't know, 100 on the next in class, 100 on that in class. The first quiz, they fell apart a little bit, got a 72. This homework, let's go with, I don't know, tell me some scores here, come on. 0 on a homework? No way. No.
89.
How about a 95 on a homework? Here's an in class, let's say they got a 98. I heard 90 what?
89.
Do you got an 89 on a homework? Okay, we don't have an in class there, we don't have an in class there. Week 8 homework, let's say someone got a 95. 100 on week 8 in class. Quiz 2. Quiz 2 did a little better, right? We all did a little better, didn't we? Let's give it a 76. 72 on the first quiz, 76 on the second quiz. Week 9 in homework, we kept it going. Week 9 in class. Week 10 didn't have homework. Week 10 didn't have an in class. And all we have left is quiz 3. In quiz 3, most people did not do as well as they did on the first or second quiz. There are some who improved, but very few compared to most people. So I'm going to say this person only got a 70. So now, with all that said, everything I have the weights moved over for, there's a grade in. So this grade, at 62 or 63% of the class so far, has what grade? Letter-wise, they got a 70, a 76, and a 72 on the quizzes. What do they have letter-wise as a grade in the class right now? B what? Minus. What do they gotta have to get a solid B?
84.
82.5 or higher. Because I go one digit to the right, 82.5 would be an 83. That's a B. 82.5. So here, I would start estimating, I'd start moving weights over and estimating my other grades, and I would see what I need on the final exam to get that grade I want. If I want that B, I need to see what's the worst I can do on that final exam to get that 82.5, to get that B, if that's what you're going after. I just start moving weights over on these other items.
When's the final?
Okay, the final is going to be December 12th at 11:30 right here in this room, but we're starting it December 7th at 11:05. What? What's so funny? I'm giving you 5 minutes to get here. We're going to start it on December 7th, on that Thursday. So we're going to end our last lecture on December 5th, Tuesday. Our last in-class assignment, our last homework will be due on Thursday the 7th, and we'll have a third of the final ready to go, probably one of those 40-minute timed, and then you're going to have another hour something on December 12th. What day is December 12th, by the way? Is that a Tuesday or Thursday?
That's a
Tuesday.
Wednesday.
No, it can't be. It's Tuesday.
Yeah.
11:30 a.m., not 11, which means that if you have a class at 9:30, that final is not getting done until 11, probably, or the amount of time allowed. That's why they're starting this at 11:30 instead of 11 to give everybody time to get to the next class. Remember, the finals are scheduled where they never cross each other. So I don't want anyone to think, oh my God, I got 2 finals at the same time. You're misreading the final schedule if you think you got 2 at the same time, because they're designed to never cross.
Will you tell us what's on the first third of the exam? Or
On the last lecture, I do have a little surprise, give me of information, yes. Does that help? You know what I'm talking about?
No.
Well, I can't tell you, it's a surprise. Yeah, show up.
I feel like the multiple choice questions aren't an accurate representation if you understand the material or not.
I agree. I second that.
Because I got a 72, and I lost 25% on multiple choice questions.
Damn.
I feel like it's too much.
I feel you. You know what's crazy is how well you did on the multiple choice in the previous quiz.
Yeah, I got
told
lucky.
you this
I
was the
guessed
hardest
them.
test.
You know what's funny is, you just got to tell me it's the easiest test.
Who said that?
Oh, I don't wanna call him out, he's got tires on his car. You know, so there's no way I'm gonna mention who it was. Man. All right, can we get started?
No, more time.
Wait. We're not starting there, we're starting here. No, we're not even starting there either. Let's just throw this quiz out.
I agree.
Just drop your lowest quiz, like those other
Yes.
classes.
I am good with that.
Stop. Look, I'm just teasing. You know this is open book, don't you? You know it was open note, right? I mean, do you have open note, open homework answers, open everything, and any of the other tests you have in other classes?
Online classes.
So, I mean, come on.
Yeah.
Open, everything's open, please.
Is the final cumulative?
Yes, matter of fact, about, did I just see you swear? Yes, the final exam will be about, hang on, I gotta remember the percent. It's like 40% new material, starting today's new material, and 60% past material. But here's the big hint about past material. It's almost always the main subjects that we had in the past. Poisson, normal, exponential, binomial, uniform, all independent events, only because I want to get you again. You know, whatever.
So similar to the quizzes?
Similar to the quizzes, I don't change anything. My style is the same throughout the whole thing. You should, matter of fact, you guys should be at the point to be able to tell me what's gonna be on the final. That's where you should be at. I mean, I'm so predictable. There were no surprises on this quiz. Everything was exactly related to the homework. You know, except for the multiple choice ones I put on there specifically for random. So here is week 11's instructions. Yes, homework's due a week from today on the 14th. There's one document for homework because both the written and Excel are on one document. Get the Excel now, you're writing your answer out like a test question. I want the whole Excel equation and the result just like a test question. That's exactly how the final's gonna be, is you're gonna be writing out these Excel equations. So that's how it's gonna be on the homework. Did I open the homework? I hope I did. Yes, let me get it bigger here so we can see it. So you have 1A, 1B. A is doing it manually, B is doing Excel for all of these. Number 2, number 3, number 4, number 5, number 6, and you think it ends there. Number 7, A and B. Number 8, A and B, and that's it. So 16 problems. Here's the hint. Every one of them is normal distribution probability. Normal. Normal. Remember this? Equals norm.dist. X is whatever you're being asked about. The mean that's being described, which may have to be adjusted depending if it's in the same interval as what you're being asked about. The difference today, starting today, is that third item is no longer your standard deviation. It's now the standard error. This is the new formula from this point on, which is really the same exact formula, but our sample sizes have always been 1 before this day. Now your sample sizes are no longer 1. And if it is 1, you do it just like this, we'll put a 1 there. The square root of 1 is 1. Standard deviation divided by 1 is the standard deviation. How do you put this here? You should write this Excel equation, and that third number should be this full standard error. The standard deviation divided by the square root of the sample size. And don't forget, where's my pen? We learned last week how to write this out. SQRT, and the number of whatever the sample size is goes in those parentheses. SQRT is square root that we got to use from this point on in our Excel equations. for normal distribution for this homework assignment. Now, I'm sorry, go ahead.
What's the equation all the way on the left?
This one right here, standard deviation divided by the square root of the sample size. That's called the standard error. That's the denominator part of the manual normal distribution equation. This is going back you guys to week 4, I think. Whatever you're being asked about, minus the mean, divided by the standard deviation is the old formula, but now it's divided by the standard deviation over the square root of the sample size. You gotta do that subtraction, and you gotta do the square root and divide into the standard deviation before you divide the denominator into the numerator. This dividing the denominator into the numerator is the last step. Let that be the last step, order of operations. Everything's turning off here. Now, what I want to point out about each one of the A's on your homework, it's asking you to solve it manually using this, but once you get Z, you must use this to replace looking at the Z table. No looking up Z table for all your A's on your homework is to solve manually to get to Z, and then give this equation with that Z you just calculated in it, and the result. These are all the A's. The A's are combining that equation with this norm S distribution. Excel, every one of the A's. The B's are all about this equation right here, up top here, the old-fashioned NORM.DST. So these are all the B's, and these are the A's of your homework. And there's 8 of them, 8 A's and 8 B's. Does everybody understand what's due a week from today? Yes, go ahead.
Is that a S or a Z in the middle?
This one?
No,
This one?
no. The other one to the left. In the equation, norm dot, what is that, S or Z?
This right here?
Down.
Here?
Yeah.
That's an S.
Alright.
Norm dot S dot DIST. Okay, so now we gotta review a few things. We're gonna start by reviewing, did we talk random sampling? I wanna make, you've gotta understand random sampling. You gotta make sure how random sampling is done, and that statistics only works if you're truly doing random sampling. Randomness is the key. Now, several weeks ago, I brought this up for you to see. I can't remember how deep we went into talking about it, but this is the old-fashioned way of having random numbers, all right? And I can't remember if we talked about this particular situation where a manager needed to use random sampling to be able to answer a question, you need to use statistics. So let me ask you this. Does this sound familiar? You're the admissions director at this college. Does this sound familiar? And you have 900 applications that you've accepted, and you've got to go to a meeting. And at this meeting, they're asking you to report 2 things. The average SAT score, the mean SAT score of these 900 applicants that we're accepting, and what % of them said yes, they want to live in student housing, so the housing director can start getting set up, they know what to expect. You don't have any of these 900 applications entered into the system yet, but you need to have this information like in 15 minutes to go to this meeting. And so you decide to use statistical inference. Let me make sure you understand what that means. It means as long as your sample size is at least 30, that used to be the standard. There are samples smaller than that, but as long as your sample size is at least 30, that's kind of the golden rule, you can infer certain things about what you find out about that sample to the population. So we're gonna pick out 30 of those 900 applications, and we're gonna find the mean SAT score. And we're gonna see how far off we were from the actual one. So what's the process of random? Well, let's pretend we're gonna use these random numbers. Now this should sound familiar because I think we looked at these before. In the old days, you would have pages of these random numbers, and someone would say, because we're in a class, we all wanna use the same random numbers, but we want it to be truly random. And these numbers have nothing to them. They're just random numbers. How many digits? 5 across, each one? And there's how many columns there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 columns. There could be pages, 100 pages. So this could be on page 48. So someone will go, let's use page 48 randomly. And let's use column 2. And let's look at, we have all these applications numbered 1 through 900. How many digits do we need based on, since they're numbered from 1 to 900? So you got to look at it and go, well, what's the biggest number in these numbers of applications? 900 is. Well, how many digits is 900? 3 digits. So we need to use 3 digits off this table. So randomly, as a matter of fact, forget the second column. Someone give me a column 1 through 10 that randomly we select right now. 5. Go to the 5th one from the left over. 1, 2, 3, 4, 5. Now someone tell me, do we want to use the left numbers, the right numbers, or the middle numbers? Anybody? Left, right? Left. So we're going 5 columns over. Let me put the pointer right above it. 1, hang on a minute. 1, 2, 3, 4, 5. And we're using the 3 digits on the far left 3 digits in this column going all the way down. So let's look at the 3 digits on the first number, 297. There we go, there's the first one. I pick out 297, I put it off to the side. Next, tell me the number, I can't see it. 880, is that the digits on the left, 880? We have 900 of them, so there's an 880 here at the bottom. Boom, put it off to the side. What's next? 275, does that say 275? I'm grabbing number 275, put it off. And we keep going, 653, 767. Is that 888? I gotta get to where I can see this. 888, 403, 952. Wait a minute, there's only 900 there. You continue this process, you would skip a number that doesn't make sense, like 952, and you would continue this process till you drew 30 out. Here's the point. We had no idea what numbers we were going to use from this random table. This random table had 100 pages, and we picked page 49. This random table had 10 columns, and someone said, let's use column 5. This random table had 5 digits. We could have used the middle 3, the right 3, but we used the left 3 digits. All of that was random, including these numbers we're using. There's no rhyme or reason behind these numbers. And because of that, we can use inference. Meaning if true randomness is involved in this particular population, because there was 600 of them, or 900, excuse me, we can pick out 30, and what we find as the mean of those 30 is probably going to be pretty close to the mean of all 900 if we had time. So sure enough, let's take a look and see what we did here. Let's see what the PowerPoint says. Oh, we're not going to use a random table. Instead, look at what we're going to use. Remember this? This is from last week. Equals ran between, parentheses, 1, 900. So we'll use this to pick them out. Let's start with the first one, space. 121, okay, hang on, let me put a, whoop. 793, what's the next one? Number 100, next one, 135, this looks familiar, right? This would be the process we could use. Or we could even take and write this whole equation, ran between 1, 900, and copy and paste it down, 35, and because you're probably going to have a repeat number, then the first 30 that work, you pick them out. Again, totally random. As long as the process is random. Now here's the rule. Whatever random process you choose, I mean, you could even take all 900, throw them in the air, and try to catch 30. Whatever process you use, you have to ask yourself, did every one of the 900 have the same chance to be in the random sample? Let me repeat that. This is how you know if your random sampling works or not. Did everyone in the population have the same fair, equal chance to be one of the ones picked in the sample? That's the key to your process. And that's what you got to remember about random sampling. So now let's look at the process on this one. The admissions person says, I got to go to this meeting. I need the average SAT. Also the percent of those who are going to live in the dorm, but we're talking about that next week. So this person says, okay, I'm going to have to take an average. Let me get here. Here's 30 applications as our sample. We start drawing numbers. 744, we pulled that one out. 436. Notice 902 has an X on it because they're only numbered to 900, so we just go on to the next number until we pulled out 30 of them. Now, when we pulled out all 30, here's their SAT scores. We add up all 30 SAT scores. Here's whether they said yes or no on housing. We add all 30 SAT scores, we divide by 30, 997. Now you go to this meeting as a manager and you explain, we haven't got the applications in the system yet. So in order to provide you with some information that I think is at least a fair estimate, We did a random sample of 30 of the applications, and the average SAT score of this random sample was 997, which we can assume that the real average SAT score for all 900 is probably somewhere around 997. And as far as housing, go down here, we picked out 30 randomly out of the 900 applications, and out of that 30, 20 said, yes, I wanna live in student housing, which is a proportion, this is a proportion of the 30, 68% of them. So if you multiply 900 by 68%, that may be around how many you should plan on housing director, since you're at this meeting. And that's how it works. That's how random sampling works, that you can go to this meeting and have some confidence in what you're saying because of the process you use. What are the real numbers? 997 is what we said. The real one was 990. That's not bad, we were 7 off. 68% is what we said from our sample of 30. If we did all 900, it was 72%. Again, not far off, but that's how you can go to some meetings with some fair estimates to provide the information so people can do their job. Everybody see how that worked? So now, hang on. I'm going to there. There's some important definitions. I want you to at least write the name of each one of these, because if I'm picking some multiple choice questions for the final exam, it's probably related to some of these subjects that I'm putting on the board and that I'm going over right now. One is, I'm on slide 2 from chapter 7 PowerPoint, statistical inference. I've already highlighted it. It's inferring something about the population from the sample. And as long as you use a random process that truly gave every one of them a chance to be in that sample, you can make some inferences. You can say this is probably pretty close to what it would be if we had time to do the whole population. That's called inference, statistical inference. Now I'm going to slide 3, proper sampling method. The sampling results can provide good estimates about the population as long as you use proper sampling methods. Again, the key is that whole thing, that whatever process you use to sample, and there's a million different ways of doing it. We didn't even have to number them. We could just figure something out. We could bring a pet cat in and say, okay, put your paw on 30 of these, cat. When the first 30 the cat walks on, we pull them up. Something like that. And whatever the process is, as long as every one of them had a fair chance for that cat to walk on it. Proper sampling method. We're going to slide 6. Finite. I want to make sure you know the difference between finite and infinite population. Those 900 applications and admissions, that's called a finite population because there was no more. We were only accepting 900 students. We could even number them 1 to 900. There's no more being added to it. Application process is done. We just didn't get them into the system. That's finite because there's 900, that's it. So infinite we'll get to in a minute. Let me see, we're going to slide 7. And I want to talk about sampling without replacement. Perfect example is a manufacturing process. I've witnessed a lot of these, especially down here in Detroit area, Southeast Michigan. Many suppliers for the auto industry use statistical process control. I always like to use the example of ball bearings. A company's making ball bearings and they're going to sell it to Ford, all right? They're a supplier for Ford. They're tier 1, tier 3, whatever it may be. And they're making these ball bearings. Well, before Ford will accept those ball bearings to be shipped, they send a quality control person to their place. They got the call, hey, we have 10,000 ball bearings ready to ship. Send your person over. They send the person over. He or she then is grabbing random sample of ball bearings with a laptop with a machine there that's measuring those ball bearings and recording it one after another. Picked out 30, got a mean size to see if it's within the specs in order to accept it. This is called, and then wait a minute, the quality person goes and grabs another 30, and we'll do this process about 5 times. And then we'll either sign off on this order and now it can be shipped and will be paid for, or says no, this is not coming up as good quality and will not sign off it, and now it can't be shipped. Suppliers learned a long time ago that they never want that to happen, so they implemented their own quality control to ensure that when their quality comes over, it will meet standards. But what I'm trying to point out is that when that quality control person was taking those ball bearings out and putting them off to the side, they were not putting them back in to do the second measurement. That's called sampling without replacement, which is the most common. Sampling without replacement. Had they put the 30 ball bearings back in and mixed them up and now drawn 30 more, that's called sampling with replacement, which is common also, but not as common as without replacement. All right, let's see, we're going to 8. I wanted to point out there's situations where numbering, doing random numbers to select your sample will not work. And it's when your population is so huge that there's no way you can number all of them. There's no way of numbering them all, then using random numbers won't work. So there are situations like that. And it's usually when your population is just far too large. Now, here we go with infinite. This is hard to describe. You've got to try to, and I use manufacturing as an example because it's easiest to picture, but let's use those ball bearings. If a manufacturer has a process of making ball bearings and keeps making them and adds to the pile all the time, let's say they have 3 shifts going, the population never stops and continues to have more added to it. That's called infinite population. And that's the difference between finite. Finite, those 900 applications, that was it. We're not accepting any more. It was, you can number them 1 to 900. But with infinite means there's a continuously being added to the population. You can't use that same process. And that's called a infinite population. So that's the difference between that and finite. I'm looking at the clock. I got a couple more examples to go over. I'm gonna push those off till Thursday. I think we have enough information. All right, so Thursday I'm preparing you to be able to do the homework and hopefully have it done that night. I'll see you then.